Welcome back to the Defense Tech Podcast. This is a show where we sit down with subject matter experts in the defense tech space to gain an understanding of the biggest projects that the DoD is focused on, through the lens of the innovators that are on the ground doing the innovating. This week I had the pleasure of sitting down with Krishnendu Chakrabarty, who is the Fulton Professor of Microelectronics in the School of Electrical, Computer, and Energy Engineering at Arizona State University. He is also the Chief Technology Officer for the Southwest Advanced Prototyping, or SWAP, Hub under Microelectronics Commons. In his past, he has collaborated extensively with the semiconductor industry, and his technology solutions have been adopted by Intel, TSMC, Samsung, and more. In this episode, we discuss some of the technical projects that the SWAP Hub is focused on. He also helped me understand what their workforce development initiatives are accomplishing, further cementing my understanding of why we need to dedicate more time and energy to preparing a qualified pipeline of workers that will help us succeed in re-onshoring microelectronics manufacturing. Without further ado, I hope you enjoy this episode. All right. Hi, Krish. Welcome to the Defense Tech Podcast. I really appreciate you coming on today and filling us in on what's been going on with the SWAP Hub. So to start off, I would love to hear about yourself and how you ended up as the CTO of the Southwest Advanced Prototyping Hub.
Hi, good morning, and thank you for the invitation. I really appreciate it. My name is Krish Chakrabarty, and I'm the Fulton Professor of Microelectronics at Arizona State University, and I serve as the Chief Technology Officer of CTO of the SWAP Hub. I'm also the director of the ASU Center for Semiconductor Microelectronics, or ACME. Before joining ASU, I was the John Cog Distinguished Professor and Chair of Electrical and Computer Engineering at Duke University. I've been in academia for over 30 years, so that's a long time, leading research projects and collaborating with the DoD and industry. I received the ONR Young Investigator Award early in my career, and I received grants and contracts from DARPA and the Army Research Office, and I've partnered with defense tech companies in these programs. I've developed several key semiconductor technologies that have been transitioned to industry, and I've been recognized with awards that recognize the impact of these technology transitions.
Awesome. Great. That sounds like an awesome background. Honored to be talking to you. So could you tell us a little bit more about the SWAP Hub, the Southwest Advanced Prototyping Hub, what you guys are up to, what it was created for?
Yes, absolutely. The SWAP Hub was formed through concerted action by many stakeholders. So this was an effort that took several years in the making in Arizona and the Southwest region. Our region, as you know, has become the epicenter of the microelectronics resurgence in the country, with new fabs and a thriving ecosystem in packaging, in the supply chain, and so on. Arizona State University is a hub lead, but there is close partnership with Sandia National Labs, and we have worked closely with Sandia from the very start. We got tremendous support from the ASU leadership, as well as the state and local governments. We also have close partnerships with DoD primes such as Northrop Grumman and Lockheed Martin, and universities in the region, such as University of Colorado, University of Arizona, and University of New Mexico. Industry partnership, as you know, is key as we work on these tech transitions. And in particular, we work very closely with Applied Materials, NXP, Mercury Systems, and many startups in the region. I also would like to add that the SWAP Hub is located in Macro Technology Works, or MTW, which is a unique facility managed and run by a university, by ASU. This used to be a Motorola fab in the old days, and when Motorola closed operations here, ASU acquired it and developed it over the years, and now it supports their prototyping efforts for the hub projects. We also have the ASU core facilities, which are substantial and are available for our hub projects as well.
Great, wonderful. Thanks so much for explaining all that. So now that a year has gone by since you got awarded as one of the hubs of Microelectronics Commons, and SWAP is a bit more established, what would you say is your hub's mission?
Yes, our mission is to enable technology transition and prototyping. And this is being done to take microelectronics innovation from the lab to the fab. In this way, we can bridge what has been coined as the valley of death, and we can create commercialization pathways for compelling new technologies. And we can pave the way for new technologies to be adopted in DoD platforms. In particular, and I'm very proud of this, we are enabling startups and small businesses to demonstrate their technologies by providing them with the means for prototyping. As you know, a lot of the innovation engine in the US is in the small businesses. Historically, they have had trouble, they have had difficulty prototyping. So our hub is going to enable that. We're also focused on workforce development to support on-chip microelectronics design and manufacturing, onshoring them through innovations in training, degree and non-degree programs. And I would like to add here that we are quite unique in terms of our size. So ASU is by far the largest engineering program in the country. We have over 32,000 engineering students. And if you consider the entire ecosystem, the other universities in the region, we have 55,000 engineering students. This is a massive resource that we can exploit, that we can use to develop the workforce. In terms of our mission and capabilities, we are organized around 5 capability areas and 3 cross-cutting themes. The capability areas are as follows: rad-hard CMOS plus X integration, metrology and characterization, RF and power electronics, heterogeneous integration or advanced packaging, and circuits, architectures, and test. And our 3 cross-cutting themes are extreme environments, which is more in the rad-hard area, trust and assurance, and workforce development.
Okay, great. So as far as some of the 6 technology areas that Microelectronics Commons is focused on, what of those tech areas is SWAP focused on, and what does your hub specifically bring to the table for those areas?
This is an excellent question because we are working with a lot of project teams in these technical areas. Our hub includes all 6 technical areas. Initially, our focus was on 3. When we started off 2 years ago, we were looking at AI hardware, 5G, 6G technologies, and commercial leap ahead. However, as you saw in the previous question, we have a lot of capabilities and cross-cutting themes, and our capabilities and themes can support the other 3 areas as well. And we submitted technical project proposals in 2 other areas apart from the 3 I named just now, so electronic warfare and secure edge IoT. And then our awarded projects are in 4 of these 5 areas. So we have awards in AI hardware, 5G, 6G technologies, commercial leap ahead, and secure edge IoT. Our capabilities and themes support all these areas, and we are especially unique in our strengths in advanced packaging, especially fan-out wafer-level packaging, where I think we are really, really very strong. Extreme environments, for example, rad-hard evaluation and testing, and also metrology.
Wonderful. So you mentioned some of the projects that SWAP was awarded recently in the first round of project awards. So would you like to highlight maybe a couple of those awards that your hub received?
We are very excited by these projects because they are large teams ranging all the way from universities, national labs, small businesses, large companies, and DoD primes. So we got awarded 5 projects, 1 on AI hardware, 2 in 5G, 6G, 1 in commercial leap ahead, and 1 in secure edge IoT. Let me start with these projects. So our AI hardware project is on using a crossbar array of RURAM non-volatile memory along with the RISC processor. So essentially, it is looking at in-memory computing to process data from a focal plane array. This project is led by ASU, and our partners are Sandia National Labs, RTX, or Raytheon, which merged with Collins, and now it's RTX, University of Colorado, University of Southern California. The Secure Edge IoT project is led by a small business from Idaho. It's called Idaho Scientific. So this also reflects the reach and the footprint of our hub because we have partners from outside the Southwest as well. And the team for this project includes Synopsys, a large EDA provider, EDA company, Mercury, and BAE Systems as the DoD prime. This project is on designing and prototyping a secure processor that DoD would need. The Commercial Leap Ahead project is led by ASU, and it is on radar power converter, very high efficiency power conversion. And the project team includes Lockheed Martin as the DoD prime, Sandia National Labs again, and Thermavent, a small company which does thermal management. So we also have two 5G 6G projects. The first of those is led by NXP, and partners are ASU, Raytheon, and National Instruments. And the goal of this project is to basically prototype highly integrated power amplifiers based on GaN, gallium nitride ICs, and heterogeneous integration, which would allow these prototypes to operate over a wide range of reconfigurable bands. And the second 5G 6G project will deliver an SoC, system on chip, transceiver package that would support both communications and sensing with reconfigurability and accuracy. So this is an overview of our projects. And I must also mention that our second 5G 6G project is led by a small business called Alpha Core out of Phoenix. And their partners include ASU, Rice University, Auburn University, Lockheed Martin. So we have a broad range of projects in 4 of the 6 technical areas, 5 projects altogether. And as you see, we have ASU on 4 of those 5 teams. We are leading 2, and on the others, we are partnering. And we have a project led by Idaho Scientific where ASU is not even a member. And we really value that because it shows that our hub is very inclusive and we have projects which are run by our partners.
Yeah. Absolutely. So is there any one of those projects that you personally are the most excited about? Might be hard to pick.
I cannot pick a favorite because I'm monitoring all 5 projects, and we are very excited by all of these. And they're in 4 different areas. So you can see that we're not narrowly focused in 1 or 2 of these areas.
Right. Yeah. A very broad expansion. Yeah, that's really exciting. So I'm a little curious to dive further into the secure edge / Internet of Things tech area. I'm new to the industry, so just for my sake and for our audience's sake, could you explain what it is and where it fits into the Comet's mission?
Yes, absolutely. This is a very key area because a lot of our microelectronics now is manufactured, assembled, and packaged offshore. And there are concerns about trust and assurance. Can we trust those manufacturing facilities? Are there any undesirable, what we call Trojans in those manufactured parts? When we assemble them offshore, can we trust that they would function as intended? So the secure edge IoT area is basically, it has 2 aspects. There's secure edge and IoT. So IoT stands for Internet of Things, where we are trying to do a lot of computing on the edge with very low power and low complexity devices, but they are connected to each other and to the internet. So the power of the system comes from the interconnections, and that opens up a lot of vulnerabilities. An attacker, a malicious actor could attack these systems in many different ways. So this technical area is looking at innovations where we can look at design of processing systems and memories and networks that we could trust. So we have ways to quantify. There are metrics we could use to quantify how secure the systems are. And then we have techniques to detect intrusions or malicious behavior. And then we have countermeasures in place. So all the projects in this area, including ours, is aimed at assuring that the systems that are being utilized are trusted.
Yeah, absolutely. Thanks so much for explaining that. And then we talked about some of the projects that your hub is working on in this technical area in secure edge IoT. How will some of this technology help to re-onshore the microelectronics manufacturing capabilities in the future in the US?
Yes, I think that this is an excellent question as well, because we are trying to create an ecosystem where we do not have to invest in just one location or in one entity. We are able to create an ecosystem of partners, and the partners could be distributed could be working at different scales of complexity, could be different sizes. But when we assemble our entire system, we have to guarantee that the system would work. The system can be trusted, will not have any vulnerabilities. And also when it's deployed in the field, it could be offshore, even though the manufacturing is onshore, but the system could be used in theaters which are overseas and where adversaries could be rampant. And we have to assure that our system would still be trusted in those environments. So the secure edge IoT area, there are projects in this space, but also we have a team in our hub. We are building up a lot of capabilities that could enable our own project, but also other projects in other hubs, would allow us with the mechanisms and the techniques, the metrics, the methodologies that would detect intrusions and build up countermeasures.
Absolutely, that makes sense. So it will ensure the safety of the technology we're using, even when we partner with people outside of the US. Is that right?
Absolutely, because we will not be able to do everything alone. We'll have friendshoring and we'll have allies, and we need to make sure that we have trust built in at every layer of these interactions.
Yeah, great. Makes sense. So I'd also like to touch a little bit about the 5G, 6G technology area. Could you help explain what this tech area encapsulates and how it relates to microelectronics manufacturing?
Right. So 5G, 6G is about communications. As you know, 5G is a protocol, and now we are doing 6G and this next G. So there's a lot of activity here. So this is critical to communications and the integration of computing with communications and sensing. So we are trying to build chips or packages where we do computing with processing, but also we have sensors built in and we have communication antennas and various kind of transceivers built in. Now, this requires new materials such as gallium nitride or GaN and new kind of circuits, because that's how we would be enabling these heterogeneous technologies. And we also need these components to be integrated in a package using advanced packaging. So therefore, a lot of the innovation that we have to build in manufacturing and the supply chain integrity is driven by 5G, 6G, because we have to understand what the needs are of that technical area and then generate the specs that would be built into our manufacturing flows.
Yeah, absolutely. Okay, thanks for explaining that. And then kind of similar question to the secure edge IoT. As far as your project awards and what you're focused on, what critical DoD issue is your hub working on within 5G, 6G, and how will this help to re-onshore microelectronics manufacturing capabilities?
So our hub and ASU has always been very strong in the area of compound semiconductors. So if you think about semiconductors historically, a large driver for that was silicon. So you have what is called complementary MOS or CMOS technology that has been utilized to build very fast microprocessors and memories. But currently, there is a need for investing in what is called ultra-wide bandgap semiconductors, compound semiconductors, or 3-5 semiconductors. These are technologies that are very important for power electronics, RF electronics, and also for communications, because a lot of the process technologies that are necessary to enable low power communications and integration of optics, for example, because it's very important that we also can compute using light and be able to transmit signals using light because it's much faster. So in the 5G, 6G area, we have been working for many years in ultra wide bandgap semiconductors, looking at GaNs and other technologies. And that has been a very good fit with what the DoD has been asking for. So a lot of the technology gaps that were identified by the government and that went into the technical guidance were along in these technology areas, and we found it to be an excellent fit with our capabilities.
Okay, absolutely. Very cool. So I want to switch gears a little bit and talk a bit about workforce development, which you mentioned earlier is a big focus of your hub, and a strength of your hub because you're so widespread. So what role does workforce development play in the long-term vision of Commons, and what type of efforts is the Swap Hub leading in this area?
Um, yes, this is key because we could develop our fabs and build packaging and build all the infrastructure, but if you don't have the trained manpower, we can't really operate those. So it's very important that workforce development proceeds in parallel with everything else, so that we can also drive the innovation engine. As I mentioned earlier in this podcast, we have a very large pool of students. ASU is the largest engineering program in the country. We have 32,000 engineering students. We have 55,000 students in the region, if you include Colorado and University of Arizona and New Mexico. So this is a tremendous pool of resource for us. A lot of our students are very interested in electrical engineering, and we hope to leverage that and also bring in students from mechanical engineering, chemical engineering, which are all intrinsically connected to chip manufacturing. Beyond that, we are partnering a lot with the community colleges in the region. So Maricopa Community College in Phoenix, we work very closely with them because not everybody is being trained to be an engineer. We also need a lot of people who are technicians who will be working in the fabs, people who don't need a formal degree. We are creating, micro credentials, and we are able to create a micro badge. So we have created a sequence of courses that students could take to upskill their knowledge. We also have a large veteran population in the region, so we feel like that is an untapped potential. We could create opportunities for our veterans to get trained in microelectronics and find excellent jobs. We have a lot of companies in the region. The Phoenix area, as you know, is booming with large corporations and startups. And we are able to look at matching the job opportunities in these companies with the veterans and others we are training. And then finally, one very important aspect of our hub is our partnership with the Sandia National Labs. So as you know, Sandia is one of the premier national labs in New Mexico, and they have training programs in place already. And we are working with them to scale those up. So it's a matter of scaling up the programs that already exist, making them accessible to more people, but also looking at more programs that could be built around what exists already.
Yeah, that makes sense. It sounds like a lot of exciting stuff in the works, a lot of cool connections that you can capitalize on. Awesome. Well, that's about all the questions that I have. Is there anything else that you would like to speak on or highlight about your hub before we go?
I'd like to thank you for the opportunity to talk about our hub. So the Swap Hub has an open membership model. We are very open to collaborations and partnerships. We are very keen to partner with the other hubs. This is something we'd like to do more in year 2 and beyond, look at more of a cross-hub collaborations. We're also interested in new core and capability partners who can help our project teams and project partners.
Yeah. Okay, wonderful. So like you mentioned, if someone is looking to learn more about membership or partner with the Swap Hub, what is the best way for them to get connected?
The best way to get more information is to go to our website. So the Swap Hub website, which I will read out here, but if you do a search on Google, it'll show up right away. It's microelectronics.asu.edu/southwest-advanced-prototyping-hub. That's a website URL, but again, you can easily find it by doing a search on Google. The website provides a lot of information about our capabilities, our projects, our teams, and also our capability leads. As you can understand, the hub is not, it's not run by a small group of people. We have many, many experts who are involved in different technology areas, and their names and details are on the website. And you can also send us email. So if you would like to just drop an email, our email address is swaphub, SWAPHUB@asu.edu.
Wonderful. Okay, thank you for sharing, and thanks so much for coming on. Learned a lot about your hub, and really excited to see what you guys accomplish in the next year and beyond.
Thank you. Thank you very much.
No problem.